Welcome to the second lesson on trigonometry. This lesson talks about the sine ratio. So just a reminder, trigonometry is the study of triangle measurements. We're talking about angles and side lengths in right triangles. So as a little bit of a warm-up, I would like you to name the sides of this right triangle, looking at where theta is in the triangle. The sides are labeled B, C, and D, and I would like you to label them adjacent, opposite, and hypotenuse. Moving on, the sine ratio is very similar to the tangent ratio, but we're talking about two different sides. So when we were talking about the tangent ratio, we were talking about the opposite and the adjacent side. For the sine ratio, we're talking about the opposite side and the hypotenuse. So sine of theta is equal to the length of the opposite side over the length of the hypotenuse, using these as short forms for the sides. So the formula we work with is sine of theta is equal to O over H for opposite over hypotenuse. So this is the one we're going to be working with in today's lesson. Okay, the steps for finding an angle, if you know some of the sides, are almost the same as finding the tangent. So step one, you identify the sides, the hypotenuse, the opposite, and the adjacent side to angle theta, just like when you're finding the tangent. Determine the sine ratio this time, so S sine of theta equals O over H, and then you solve for theta by plugging in the numbers you know and solving. So for our first example, we're given a triangle here. We know theta is right here, and we're given the lengths of all three sides. So step one, we're going to identify the hypotenuse. We know that one because it's across from the right angle. The opposite side is the one not touching theta, and the adjacent side is the one that is adjacent to theta, it's touching theta. Step two, the sine ratio. Right, sine of theta equals O for opposite over H for hypotenuse. And we have sine of theta is equal to, well, our opposite is 42. Fix that too. Hypotenuse is 100, so we have 42 over 100 on the right side. When we rearrange, just like we did for the tangent ratio, we find that theta is equal to the inverse sine of 42 over 100. When you type that into your calculator, you're going to do second function or shift and then the sine button so that you end up with the inverse sine shown on your calculator. Then you put 42 divided by 100 all in brackets, and you will end up with theta is approximately equal to 25 degrees. Okay, similar setup to how you were solving for the tangent ratio before. To find the unknown side, if you're given an angle and another side, you, again, step one is identifying the three sides. Step two, write down the sine ratio, the formula, sine theta equals O over H, and then you solve for the unknown side. So here's an example of that. We're given a triangle. We have an angle of 56 degrees. We have H for the height of this triangle, and we have the hypotenuse is 73 meters. So I'm going to start by labeling my sides. Hypotenuse there, A there, O there for adjacent and opposite. Step two, we write down our formula. So we have sine theta equals O over H. opposite over hypotenuse, sine of 56 degrees is equal to, the opposite we don't know, but it was called side h for height, over the hypotenuse was 73. Rearrange this, so you're going to multiply both sides by 73 to isolate h. You have 73 times sine of 56 degrees will give you h. Type that into your calculator, 73 times sine 56, and you'll find out that h is approximately equal to 60 .5 meters, because this was given in meters.